Hello and welcome to the beginning of trigonometry. In this video we're going to be covering the beginnings of trigonometry and talking about what's called the trigonometric ratios, which you're going to see in a second what the three main ones are. For the purposes of this video, we're going to be using the trig ratios to find missing sides of a right triangle. So very specifically, these ratios are only to be used when you have a triangle with a 90-degree angle right there. If it does not have a 90-degree angle, then you can't do anything that we're doing today. At least in this. When you get into further subjects, you can use trig for other stuff, but trig ratios are only going to be for 90-degree angles. But the thing is, like, you've worked with 90-degree triangles before, mostly with the Pythagorean theorem. It's something you've done a lot. The Pythagorean theorem says a squared plus b squared equals c squared. And you can use that when you have two sides of a triangle and you're trying to find the third. For example, if we were given 8 and 13, and you wanted to find this, you could just do 8 squared plus 13 squared equals x squared. And then you would do some math and you'd be able to solve for x. So that would be 233. And then you could just square root both sides and you get an approximate value of x. So let's say square root of 233. And you could get right there, it's approximately 5.26. I'm sorry, 15.26. So you can use the Pythagorean theorem to find the third side of a right triangle. But it's like, well, what happens in this scenario over here? Where I know this side is 8, I labeled this y, and I labeled that x. You still have three sides, but this time only one of them is actually labeled as a number. So if you were to try the Pythagorean theorem, you could have 8 squared plus y squared equals x squared. But there's not much else you can do with that. Sure, you can make that a 64, but like without knowing what y is, you can't solve for x, and without knowing what x is, you can't solve for y. You just kind of get stuck here. But it turns out if you do know one of the angles here, you can still find out everything that you need. The reason for that, I'll try a visualization. Let's pretend for a second that this is a known side of a triangle. I'll have to zoom out. So this is a known side of a triangle. And let's just say that this right here is an angle. My hand is an angle. This is the 32 degrees, if we're going off the numbers on here, right? 32 degrees. So we're just pretending that my hand is 32 degrees. And that 8 right there is the marker. If I wanted to make this into a triangle, like, you know, this isn't a triangle because this is not matching with that. Same thing here, I could make that match that, but it's not connecting into an actual triangle until I like move my hand about right here, where this would match up if my hand was bigger to make a triangle. But there's only one place that can happen. If I go further out, then it's going to be too tall. If I go down, then it's not going to match. If I go up, it's not going to match. So like, there's only one place where I could put my hand so that would make a triangle, which means that there exists only one triangle that matches this length and this angle, which means you should be able to just get a tape measure and measure this and measure that. So I'm saying this just to show you that it should make sense that you're able to solve this triangle, that you should be able to find this length. You should be able to find that length because you can imagine it. You can imagine this one angle coming in and making a triangle, and there's not more than one option. So the question is, well, how? And that's what this is. It is trigonometry. The three main trig things we're going to be talking about are sine, cosine, and tangent. Forgive my ink. There we go. Now, when you write out sine, cosine, and tangent, you can see down here that it says sin, cos, and tan. That's just shorthand. It is sine, and sometimes they'll use x, sometimes they'll use this Greek letter called theta. Lowercase Greek letters are usually used to denote angles besides just x. So you'll notice that on some problems. You'll see a theta instead of an x, and it just means an angle. So sine of theta, we'll use cosine of theta, and tangent of theta, things like that. But it is just a notation. This does not say tan, cos, and sin. It is sine, cosine, and tangent. So make sure when you are saying them out loud, you are saying sine instead of sin, cosine instead of cos, and tangent instead of tan. Okay, these are actual definitions now. Sine is a ratio. If you forgot what a ratio is, a ratio, well, it either means a fraction or just a comparison of two sides. But we're going to be talking about it in terms of a fraction in this unit. So it's going to be a fraction. And that fraction is the opposite side divided by the hypotenuse. And it's just going to be a number like 7/12. Boom. Cosine. To save time, I'm just going to do this for all of them. Okay, so cosine, this time it's the adjacent side over the hypotenuse. So it's if you have these two sides of a triangle. And then finally, tangent, it was the opposite side over the adjacent side. I'm sorry, yeah. Here we go. Boom. So in all these cases, you have two but not the third side. Two but not the third side. Two but not the third side. And that's going to tell you whether you want to use sine, cosine, or tangent. We have talked about before in a different video the difference between the opposite and adjacent side, just in case you need a review of that. If you have an angle right here, then there's technically two adjacent sides. This side is adjacent and this side is adjacent because they're both next to the angle. So, you know, this would be adjacent and that would be adjacent. But in this unit, since we're considering the hypotenuse a completely separate side, we're only going to be labeling the other side the adjacent side. Meanwhile, the opposite side is like if you were to go inside of the triangle across to the other side would be the opposite side. So that's what's meant by the opposite side. On the other hand, I could like choose this angle up here. In which case, you know, if we're looking at hypotenuse, opposite, and adjacent, then in this triangle, the hypotenuse would be here. If this is the angle, then this is hypotenuse, so this one would be adjacent, and then opposite would be the, you know, opposite. So this would be the three sides. And this is definitely the most important thing that you need to know for this video, how to identify the opposite, adjacent, and hypotenuse. So what I'm going to do for you is I'm just going to draw some triangles, and I want you to see if you are able to figure out which side is opposite, adjacent, and a hypotenuse. So I'll go here, here, and there. If those are my angles, see if you can figure out which side would be the hypotenuse, which side would be opposite, and which side would be adjacent. You know, pause it. Okay. So I always do the hypotenuse first. This would have to be the hypotenuse because hypotenuse is always across from the right angle. If this is the hypotenuse, then this has to be the adjacent. And if that's adjacent, the only thing left is the opposite side. And this other one, like I said, I like to do the hypotenuse first, just to get out of the way. If I wanted to do opposite second, then, you know, if this is the angle, then going across this would be the opposite. And the only thing left is adjacent. There you go. So that would be opposite, or this would be the hypotenuse. And this is next to it, so it'd be the adjacent. Like that. So hopefully you got those. But you'll be getting lots of practice with it because it's comes up in every single problem ever. And next comes this saying that lots of mathematicians use called SOHCAHTOA right there. And it is just something to memorize because memorizing these 6 things, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, while tangent is opposite over adjacent. That's like 9 things you're having to memorize, 9 words rather. But if you remember this one phrase as an acronym, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA is how they pronounce it. If you can remember that, then you'll never have to memorize the rest of it again. So I highly recommend just like pausing the video and just saying out loud SOHCAHTOA a couple of times, either, you know, with your voice or in your mind, but get into muscle memory of just memorizing it to save yourself the headache later. SOHCAHTOA, 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 SOHCAHTOA. That's right, I'm spending like 30 seconds doing nothing but saying SOHCAHTOA, so it gets stuck in your brains and you don't forget it. SOHCAHTOA. All right, SOHCAHTOA. Let's try setting up the 3 trig ratios. Here we go. Start with the angle that we know. And I'm going to write down SOHCAHTOA. Like so. And the way you're going to be writing this is first you will see that it says x, so I'm going to write down sine of x equals. And since sine is opposite over hypotenuse, I have to find out which side is the opposite in hypotenuse. So we're going to do what we did on the back of this sheet on my scratch paper. From this right triangle, I know this is the hypotenuse. Hopefully you have the practice. See if you know which side is opposite and which side is adjacent. So which side do you think? So opposite and adjacent. So if sine is opposite over hypotenuse, that would be 9 over 15. For cosine of x, which is adjacent over hypotenuse. Feel free to pause if I go too fast, but cosine is adjacent over hypotenuse, 12 over 15. And finally, tangent of x. That is supposed to be opposite over adjacent. So opposite over adjacent, 9 over 12. And then you simplify the ratios. So sine of x equals, all of these are divisible by 3, so just divide them all by 3. And you would get 3/5, 4/5, and 3/4. Those are the 3 trigonometric ratios of this triangle. There you go. That's how you do it. 2 quick things to end off the video. First of all, writing down SOHCAHTOA. I sometimes write it like this. SOHCAHTOA. I just wanted to show it to you. If you're one of those people who it's like, okay, I understand the letters, but how do they work? It might be better to write it this way. Like, you still say SOHCAHTOA, but writing SOHCAHTOA It might be more valuable because it also reminds you that the answers are supposed to be fractions. Like sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. So maybe just writing it like that would be beneficial to you. It's up to you. I don't need to, but you might need to. So could Toa. The other thing, completely not mathematical, you might notice the way I write tangent. You see here I hook my t's a little bit. I like hooking my t's on tangent simply because sometime in the future you might be doing things like sine of x plus tangent of x, something like that. In which case, you know, if I zoom up, it looks weird having a plus and then a t next to each other. It gets kind of confusing. But if you hook the t a little bit, then it's just a little bit easier to read sine plus tangent, because the plus sign the plus sign still looks like a t, but this t is like definitely a t and not a plus sign anymore. So that's why I do that. Feel free to do it or not, but just a little tiny hook on it so it doesn't get confusing in the future. That's it. Have a great day.